Thank you so much for joining this lesson. We shall be discussing the Mokasa 2 Joint Examination 2025 July. This one, we're going to focus on the section 1 first. Remember to subscribe. Remember to share so that you may invite a friend to our broadcast. The dimensions of a rectangle in number 1 are 40 centimeters and 45 centimeters. If there is an error of 5% in the measurement of its dimensions, find the percentage error in calculation of its area. Therefore, we have an error in the recording, and that translates to another error when we compute the area. Therefore, let's check the error in the recording of these dimensions. It's a 5% error, meaning that with 40 centimeters, this can either be 95% to give us the lower limit because there's an error of 5%. And this is going to be 38 centimeters, or the same 40 can go up to 105, the upper limit of the same. So the upper limit of this dimension is now going to be 42 centimeters. Yeah, 42 centimeters. Then there was the same error for the length. The length is 45. So when we consider an error of 5%, this can go up to a minimum of 95, giving us 42.75. Then it can also raise up to a maximum of 105% of the same value to give us an upper limit. So it's not all the time when you'll be given, it's not all the time that you'll be given, you know, the accuracy as a certain decimal places. This time around, the accuracy has been given as a percentage of whatever has been recorded. So with the maximum and minimum values of each dimension, then we can proceed to get area maximum. The maximum area will be given by the maximum width times the maximum length. So we pick 42 times 47.25. This shall give us a value which is equivalent to 1984.5 square centimeters. Then we are also having an area minimum. So the minimum area shall be when we pick the minimum length and we also multiply by the minimum width. So we pick 38 this time round, and 38 be multiplied by 42.75. So 38 times 42.75, this will give us 1624.5 square centimeters. That is now the minimum area. With all that, we can proceed to actual area. Actual area is also called the working area, whereby we need to compute area now using the dimensions just as they were captured. So 40 by 45 to give us 1800 square centimeters. Now with this, we can talk about absolute error in the computation of these areas. Absolute error is usually given by maximum minus minimum over 2. Maximum minus minimum area. This should be divided by 2. 1984.5 minus 1624.5. Then we divide it by 2. 360 over 2 gives us 180. So this is what you call absolute error in the computation of the area. So we can now talk about relative error. The relative error is given by absolute error out of the working area, or rather the actual area. Then after relative error, we will talk about percentage error. The percentage error is usually given by relative error multiplied by 100. We make it a percentage. So this will give us 10%. Yeah, that is 10%. So that's how simple the number one is. We can proceed to number two as I continue creating awareness about our programs. For the candidates of this year, we are having a mentorship mathematics program for grade 9 students. We'll be meeting every Saturday from 7:30 to 9 p.m. Then for the Form 4s, the students now who are expecting the KCSE will be meeting on every Sunday from 7:30 to 9. This is an interactive program happening via Google Meet, which is very interactive. In Google Meet, you can ask questions, you can respond to questions, you can seek more clarity as we learn together. To the continuing students, we have the one-term ahead program whereby we'll be starting it from 20th November to 12th December. This one is meant to cover term 1 work of 2026. Therefore, when we talk about grade 7, 8, and 9, then we mean the learners who are in grade 6, 7, and 8 respectively now, because there will be 7, 8, and 9 in 2026. So we'll be covering the term 1 work. We also invite the senior school students, whereby we'll be covering the Form 4 and Form 3 work. And that means those who are in Form 2 now will be proceeding to Form 3. Those who are in Form 3 now will be proceeding to Form 4. This program is meant for them. You can as well reach out for registration of the same program. Our number is already attached on the screen. So this is our number for consultations and everything else that you'd like to know about our programs. Now at number 2, solve the following pair of simultaneous equations: x plus y equals to 1, x squared minus 2x, xy plus y squared equals to 4. When you look at this carefully, you discover that it is a simultaneous quadratic. Simultaneous and also quadratic. Therefore, from equation 1, this is an indication that we can't use a elimination method, and we can also not use what you call the matrix method. We have to narrow it down to substitution only. So from 1, we can say that x equals to 1 minus y. So that if this is from equation 1, then equation 2, we substitute x with this expression. So instead of x squared, we'll talk about 1 minus y. Then this has been squared minus 2 multiplied by x multiplied by y. So instead of x, we're talking of 1 minus y, then times y plus y squared equals to 4. We can expand 1 minus y squared. This becomes 1 minus 2y plus y squared. Then, in the other bracket, remember we are having a, if we open the bracket using 2, it shall be 2 minus 2y. Then there is a y which is outside the bracket, and that can make this one now a negative 2y. Then we have a positive 2y. A positive 2y, which is supposed to be multiplied by y. That becomes positive 2y squared. You see that? Then plus y squared. This is equal to 4. Grouping of terms, grouping of like terms. So when we talk about y squared, we have again 2y squared, and we are now having y squared. So that makes it 4y squared. At that point, we are also having minus 2y and minus 2y. That makes it again negative 4y. Then something else that we have is 1, but 4 becomes negative to the left-hand side. So it will be 1 minus 4. making it a -3. This is equivalent to 0. If that is equal to 0 now, it means we have already established our quadratic equation. So we proceed to solve it. Remember, there are very many methods you can use to solve a quadratic equation. Now that we have some Form 2s on board, following up with this program, I would like to embrace the factorization method, whereby we need factors whose product is A times C. A times C means 4 times a -3, that's -12. Then there are some of the same factors equals to the value at B. The value at B is -4. So which are these two factors? Their product, -12. Their sum, -4. This is -6 and +2. Multiplied to give us -12. Added to give us -4. The easiest way of finding the factors is always factorizing the product. I don't know whether you've heard that well. You factorize the absolute value of the product. 12 can be factorized by 2. This gives us 6. If this first factorization doesn't lead us to what we want, we continue factorizing. But just at that point, look at 2 and 6. The product of 2 and 6 is 12. And depending on how we manage the signs, for us to get a product which is negative, one of them should be negative. It can be just 2 and 6. So we talk about when we make 2 negative, we shall have -2 times 6, giving us -12. And -2 plus 6 becomes +4. So we need to see how we will arrange these two factors to agree with the signs on both the product and also the sum. So what if we interchange and we make the 6 negative? It will still be 2 by -6, giving us -12. That agrees with the product. And again, when we take +2 plus a -6, we'll get now to -4. And so we can conclude in the two factors, it is the 6 which should be made a negative. Then now you proceed. We can now rewrite our equation for y squared. Instead of -4, now we consider the two factors listed. We can have -6 x +2 x. This is y, sorry. These are y's. And remember, we've not changed the value of -4y because you've just re-expressed it. We have split it into -6 and +2, which still amounts to -4. All right, we have a -3 now equals to 0. Look at this. Just look at that. From the first pair of the factors, we factorize. So from the first two terms, what can be factored out? If we factor 2y, we shall remain with 2y minus 3 that way. Then in the second bracket, it is only 1 which is common. So we shall remain with 2y minus 3. When we're doing factorization method, also in this topic, whatever you get in the first bracket should appear in the second bracket. Okay, now from inside the brackets, there is something common, that is 2y minus 3. We enclose the bracket. Then outside the brackets, what are we having? We're having 2y and a +1. This now equals to 0. Remember, when you are solving the equation again, you're not supposed to drop the 0 at any point because this is an equation, not an expression. If the product of the first factor and the second one gives a 0, then it means one of them or both of them is a 0. For us to get a 0, we should be multiplying something with a 0. I don't know whether you get that logic now of proceeding to equate each to 0. So either 2y minus 3 equals to 0 or both of them, or 2y plus 1 equals to 0, because we cannot have a 0 unless one of the factors or both of them is a 0. 2y from the first one now equals to positive 3 when we take the negative 3 to the right-hand side, so that the value of y now becomes 3 out of 2, which is 1.5 together there, or the value of y, because we're having 2y, is negative 1, then y shall remain negative 1 out of 2. We have gotten the possible values of y. And with this now, remember we have an expression for x. At the starting point, we expressed x as 1 minus y. So we can say we have corresponding values of x depending on the value of y. So when y equals to 1.5, then the value of x shall be 1 minus 1.5. So this gives us the first value of x. 1 minus 1.5. This gives us negative half. What about when the value of y equals to negative half? What are we going to get as x? Then x shall be 1 minus negative half. You're not supposed to forget that. Yeah. When y is negative half, then x shall be 1 minus a negative half, which becomes 1 plus half, and that is 1.5. So we have the possible values of y, each with the corresponding value of x. Yeah, so the values of x are conditioned to the value of y that you substitute. Number 3, without using a calculator or mathematical tables, evaluate, leaving your answer in the form a the root of b plus c, where a, b, and c are integers. Master the word integers. Some other times you'll be told where a, b, and c are constants. That's a very different question. When you talk about integers, we simply mean the counting numbers, positive or negative, including the 0. But now when we are told that they are constants, it can be even a fraction. So for this case, you expect them to be whole numbers. Let's proceed to the solving of the following question without mathematical tables, according to the examiner. Remember, for us to get the trigonometric ratios of the special angles without involving the calculator, rather getting them in fractions, we can get them in fractions and SURDS. We take a quadratic, okay, we take what we call equilateral triangle, 2 sides each. Then, of course, all the angles are 60. This is 60. This is 60. Then now we bisect one of the 60s. When this 60 is bisected, remember we are getting a right angle here, and this angle automatically becoming 30. So we have 30, 60, and 90, meaning that we can apply the simple trigonometric ratios on this triangle. After bisecting, this length becomes 1 and this one becomes 1. Then we can get the vertical height of this particular triangle, where we say a Pythagoras theorem. 2 squared minus 1 squared, then we obtain the square root. So 2 squared is 4, 1 squared is 1. You subtract and get 3. So the square root of 3 becomes the vertical height. If the square root of 3 is the vertical height, then we can express a few trigonometric ratios here, more so the tan of 60. So with reference to the 60 here, we can say that the tan is given by opposite side, tan 60. Opposite side, which is the root of 3, divided by the adjacent length to 60, which is just 1. So it remains the square root of 3, that is tan 60. Remember this, ladies and gentlemen, even when you pick your calculator and you write tan 60 equals to, the value that you get will be very equal to when you use the same calculator and write square root of 3. You get the same thing. That is 1.73205, like such. Okay, when we talk about the cosine, because the other trigonometric ratio applied here is the cosine of 30. We check now with reference to the 30 on top there. Cosine is usually given by adjacent length out of hypotenuse. So we talk about the length adjacent to 30. That is the root of 3 out of the hypotenuse, which is just 2. So now we can substitute these two trigonometric ratios in the expression, provided the root of 3 out of 1 minus root 3 over 2. Then we start now the simplification process, whereby we will talk about multiplying the denominator with the conjugate. You don't have to make it a different step. You start working automatically. 1 plus the root of 3 over 2. That is the conjugate of the denominator. And just to ensure that the value of this expression is not tampered with, we multiply even the numerator with the same. Multiply the numerator with the same that way. So we can open the brackets on the numerator such that we have the root of 3 plus, root 3 is also supposed to multiply root 3 over 2. Root 3 over 2 becomes root 9 over 2, and root 9 is 3 out of 2. So that's what we have on the numerator part. Then it should be divided by, this is supposed to be divided by, how do we solve the denominator? When you look at it, this is a simplified difference of 2 squared. A simplified difference of 2 squares. Therefore, with a simplified difference of 2 squares, we can just expand it. We take the first part squared, which is 1 squared, then we subtract the second part also squared. So this becomes 1 squared is just 1, then minus the second part squared, that is root 3 over 2, we square. That becomes, when you square, root 9 over 4. So root 9 is a rational number, which is a 3, then over 4. We are talking of the root of 3 over 2. When we square, we shall get root 9 out of 4. Then root 9 is a rational number, so it can be solved to 3. We get 3/4 that way. So that's what we are applying at that step. Again, I must remind you the mathematical identity that we are applying, difference of 2 squares. When we have A plus B multiplied by A minus B, this one simplifies to A squared minus B squared. So this is now a difference of 2 squares. So instead of expanding in the long method, we are applying this directly to get the right-hand side. So we just pick 1, we square it, and we subtract root 3 over 2, also squared. So we've applied the quadratic identity about the difference of 2 squares. Okay, now we can proceed. Remember, on the denominator now, we can subtract. That process is called rationalization. Rationalization is ensuring that at the denominator we have a third. Anyway, it has already become a quarter now after subtracting. So we are having the root of 3 plus 3 over 2. Then now we are dividing by a quarter. To divide by a quarter means that we can multiply everything by 4 now. We can multiply this by 4. Yeah, so that at the denominator we don't have anything. So we multiply by 4 and also everything here by 4. So we'll be having 1 on the denominator, so that this becomes 4. The root of 3 plus, when we multiply 3 over 2 by 4, then the 2 cancels, and we will get 6. According to the format of the above question, we are through. We have given it in the format that they needed. Otherwise, this can still be, it could have been simplified further because 2 is common. And this equation, okay, this expression is not in its simplest form, but it's in the format the examiner wanted. It is in the format wanted by the examiners. Only that you should know that 2 is common here. So we can remain with 2 root 3 plus 3 that way, though we were not advised to simplify to the latter. We were just to give it in the format stated by the examiner. So you could have proceeded otherwise. Now it's number 4. Remember, ladies and gentlemen, that our consultation line is 0704153366. So you can consult, you can reach out to us. Number 4, a quantity y varies partly as x and partly as the square of x. When x equals to 20, y equals to 45, and when x equals to 24, y equals to 60. Find y when x equals to 4. At this now, we first express the variation between the two quantities here. Y is varying partly as x and partly as the square of x. So when you hear partly, this is partial variation, and we'll have two parts. So y can be broken down into that. But again, we're supposed to know this. We can do away with the symbol of proportionality by introducing an equal signs and two constants for each of the parts. So we can say y equals to, we put an equal sign instead of the symbol of proportionality, then we introduce two constants. So this can be k by x, then c by x squared. That is the general equation connecting x and y. With that, we can now find some equations according to the provided information. X equals to 20 when y is 45. So where there is y, 45, x being 20. So 20 by k, sorry. Then here, you square the 20. So instead of doing 2 steps, you can say x squared is 400. Then times c. This is equation 1. Then there is an equation 2 from the second statement provided. We find, okay, x equals to 24 when y is 60. So this is 60. When x is 24, 24 by k. And 24 should also be squared to give us 576 multiplied by c. That is equation 2. So from the conditions provided, we have formed 2 equations. Now, these 2 equations can be solved simultaneously. To solve them simultaneously, we can choose any methods. You know, we have a factorization. Okay, substitution, we have a elimination, and we have the graphical method, we have the matrix method. So we choose the one that will be most convenient. Form 2s have covered elimination, and they've also covered substitution. So we can choose substitution. Matrix method is covered in Form 3, and maybe we might meet matrices as we continue. So from equation 2, you know, here, you're just supposed to express one of the unknowns in terms of the other for you to carry out substitution. So can we talk about equation 1? From equation 1, we can say 20k equals to 60 equals to 45. 20k equals to 45 minus 400c, meaning that the value of k equals to 45 over 20. This gives us 2.25 minus, when we take 400 and we divide by 20, we're getting 20, the value of c. Now that from equation 1, we have expressed k, then equation 2 can be rewritten. 60 equals to 24. Instead of k, 2.25 minus 20c. Then we add 576 multiplied by c. At this particular point now, we can say 60 equals to, we multiply 24 by 2.25. This is 54. Then minus 20 by 24. This is 480. The value of c plus 576c. At this point now, let's talk about negative 480 plus 576. This gives us positive 96. So we are having 96, the value of C at this point. Then on the other side now, we'll be having 60 minus 54. This gives us 6. So how do we get C? The value of C shall be 6 over 96. This gives us exactly 1 out of 16. So C equals to 1 over 16. Now that we have the value of C, we can find the value of K. Now, K is supposed to be given by, according to the expression at this point here, then K equals to 2.25 minus 20 multiplied by C, which is 1 over 16, that way. Yeah, the value of C has already been found. At this point now, we need to take 2.25 minus 20 multiplied by 1 and 16, or 1 over 16. This gives us exactly 1. Yeah, so K equals to exactly 1. You can still revisit the same. You can revisit the same. Yeah, I think K equals to 1 that way. So when you use your calculator well, you shall find 1 exactly. So it's 1. So now we can get to the specific equation. Now, remember, we were solving, and what we expressed first was a general equation. So now we can have a specific equation, which is having known constants, such as y equals to the value of K, which is 1 times x, plus the value of C, which is 1 over 16 multiplied by x squared. This is now the specific equation connecting y and x. With that, now we can find y when x is 4. So y shall be, x being 4, this is 4. So 1 over 16 and 4 is squared. So we talk about 4 plus 1 over 16. 4 squared is 16 that way. So we should get 5. So the value is going to be 5. We are through with number 4. Those who are following with our program, kindly remember to subscribe. Remember to share the link so that you may invite friends to the same. Looking at number 5 now, solve for m in the logarithm of x to base 2 plus 3 equals to the logarithm of x power 4 to base 2. At this point, we shall just start directly by applying some laws of indices. The laws of indices are several, but we choose the laws of logarithms, sorry, not indices, the laws of logarithms, though indices will still apply at some point as we continue. But we should know that out of all the laws of logarithms, we will pick deliberately the ones that exactly fit in this particular set. For example, with a constant like this, that's a 3. So we're supposed to consider the base, the general base applied in this, and it's a base 2. Therefore, we all know the law that says the logarithm of a certain number to the same base usually gives 1. So if this is so, then it means we can rewrite the log to base 2 of x plus 3 multiplied by the log to base 2 of 2. So we've introduced logarithms, and now we are using the log of 2 to base 2 because its value is just 1. The logarithm of a number to the same base gives 1. Then log to base 2 of x power 4. Yeah, x power 4 like that. We all know, again, that when we take n multiplied by the log of a, this can resolve to the log of a power n. N becomes a power. So we rewrite the log 2 base 2 of x plus the logarithm 2 base 2 of 2 power 3, which now turns to 8, 2 power 3. So 3 becomes a power to 2, according to the third law of logarithms at that point. This is equal to the log 2 base 2 x power 4, that way. So look at this now. We have the log 2 base 2, or let me just state the law first before I just apply it for those who are learning. We know that the logarithm of a number plus the logarithm of another, as long as the base is the same, so I can assume C, as long as the base is the same, we usually take the log to the same base, then A and B are multiplied that way. So applying this, the above equation now becomes the log 2 base 2 of x times 8. X times 8 now becomes 8x. This is equal to the log 2 x power 4, that way. So now we can't apply further laws of logarithms, and hence we can just equate the left to the right hand side. The equation 8x equals to x power 4. This shall be equal to, we can divide by x first. You know, this will become 8, and x now becomes power 3. X, which was to power 4, now becomes power 3. At this point, we can start now approaching our answer. If x power 3 equals to 8, then the value of x shall be the third root of 8, or rather the cube root of 8. The value of x now becomes 2. A very simple logarithm equation. You just have to be having the laws of logarithms in your fingertips. Yeah, you just have to be having the laws of logarithms in your fingertips. That way. Number 6. We are advised to make x the subject of the formula. Y plus x squared equals to x plus t, x plus y. So with this, we can have y plus x squared. This is equivalent to, we open brackets. We start by x multiplying everything in the second bracket. I want to take you slowly. Then plus t also multiplies everything in the second bracket. So y plus x squared equals to x squared plus xy plus tx plus ty. That way. Then we can now start grouping the terms with x together. We have x squared and x squared. When we group them together, they shall cancel out. So we remain with y equals to xy plus tx plus ty. That way, we can now group the terms with x together. Remember, it is a x that is being made the subject. And if it is so, then the terms with x can remain here. Xy plus tx, that way. Then ty, we'll have y minus ty. So ty is taken to the left. So the parts with x are already together. So we factorize x to remain with y plus t. Then here we are having y minus ty. That way. How can we remain with x? We divide through by whatever multiplies x. So y, and it's also good to know that we can still factorize this. Y plus t, that way. So the value of x equals to y into 1 minus t out of y plus t. So we've divided through by whatever multiplies x at this point. We've already made x the subject. It's also good to know that you cannot be penalized if you don't factorize here. Nobody can penalize you. You can have y minus ty, just as it is at this point. But it's also good to know that mathematical expressions should be left in their simplest forms. Looking at number 7 now, the question says that the position vectors of points P and Q are 5i plus 7j minus 6k and 2i minus 6j, 2j, sorry, respectively. A point x divides PQ in the ratio 5:3. Find the coordinates of x, hence the magnitude of vector OX. This is what we call the external division of a line, proportional division of lines. Okay, I know there are many methods of solving this, but I usually encourage learners. This is now about myself. I encourage every student to interpret these ratios until they turn into positive ratios, or rather internal division. Look at this. If I choose to make my P this point and my Q this point, then R is an external divider that way. Let's get to the ratios now. Let's get to the interpretation of the ratio. Interpreting this ratio, which is, the ratio is 5:3. So this means it is x, okay, this point x, sorry. We are having point P, Q, and x. Q, then point x is the external divider. Yeah, okay. It's good to know that if x divides PQ in this given ratio, then it means from P to where x is, we have 5 divisions. So from P to x, there are 5 divisions. Then from x to where Q is, we should move backwards now. So we moved this way, 5 divisions. Then we are moving back 3 divisions. That means we will have 3 proportions at this point, and because the total was 5, there remains 2 proportions here. 5-3 means from P to X, 5 divisions, and from X back to Q, 3 divisions. So we can now divide the proportions that way to say that we are having, at the end of the day, 3 proportions between Q and X, but now we remain with 2 proportions between P and Q because the total proportions were 5. So with that analysis now, you see, my ratios have become positive, and Q can be interpreted as an internal divider of PX. And we usually say this. Let me give the general overview of what we call the ratio theorem. Assume we are having A, B, then they are divided by a point T internally, such that we have M proportions and N proportions that way. The general ratio theorem states that when we take the proportion M and we divide by the total proportions M plus N, then because we've picked M, now we multiply this by the opposite vector, not the adjacent. We multiply by B. Then we add, we take ratio N and we divide by the total proportions. Then, because we are picking N now, we divide by the opposite vector, which is now A. We're supposed to get the position of T. That is the general ratio theorem. If that's the general ratio theorem, allow me now apply the same in what we are having here. Before I proceed to apply, allow me have the column vectors for P and Q. This is 5, this is 4, and this is negative 6k. That way. Then at Q, we are having 2 minus 2 and a 0 for k. That's why we don't have anything for k. So k is a 0. Then we have our x, which is unknown. So this can be given x, y, z. That way, x, y, z. With this knowledge now, we'll be able to proceed very quickly. So look at picking 2 out of total proportions 5. And because we've picked 2, this should be multiplied by the opposite vector x, y, z. Then when we add 3 out of, again, total proportions, and because we're picking 3, we multiply by p, 5 for -6. Now we should get the middle vector 2, -2, 0. That 2. We proceed. 2 out of 5 x plus, what are we having here? 3 over 5 by 5, giving us 3. This is equal to 2. So 2 over 5 x equals to -1. How do we remain with x? We multiply by 2 over 5, both sides. -1 times 2 times 5 over 2. There should be 5 over 2, giving us -5. Really? Not really. Not really. Please check well. We are talking about 5 over 2 times -1, which should be -5 over 2. So -2.5. That is according to x. We proceed to the y components. To the y component, we'll be talking about 2 over 5. 2 over 5, the value of y, plus 3 over 5 should multiply 4. That means 12 over 5. And this is equal to -2. So 2 over 5y equals to, I'm picking -2. I'm picking -2. Then I subtract 12 over 5. That's clear? So I get -4 and 2 over 5. Then now we can remain with y by multiplying every side by 5 over 2 to remain with y. So by 5 over 2, this gives us exactly -11. We proceed to the z component. So from the z component, what are we having? We have 2 over 5, the value of z, plus 3 over 5 by 6, that becomes -18 over 5. This is equal to 0. So will be 2 over 5 z equals to 18 over 5. It becomes positive. So how do we remain with z? We multiply by 5 over 2, both sides. So 18 over 5 by 5 over 2. This gives us exactly 9. So with that now we can say the position vector OX equals to -2.5 I minus 11J plus 9K. Now the position vector OX. To find its magnitude, we call it OX magnitude that way. We should pick X, which is 2.5, negative, we square, plus 11, which is also negative, we square. Then there is 9, we also square. And we take square root of everything. We take the square root of everything. So we'll be taking the square root of everything at the end of it all. So the vector OX will have a length equivalent to what? 2.5 squared plus 11 squared plus 9 squared, 208.25. Then the value of OX now shall be given us. Do we have any instructions about decimal points or that? No, we don't have. So we just pick square root and we ensure 4 significant figures. 14.43 units. So that is the magnitude, rather the length, the size, the modulus. Very good question. A very interesting question. We proceed to number 8. A jewelry is guarded by, so a jewelry room is guarded by 3 policemen, X, Y, Z. The probability of a thief being caught by X is a third, Y is a fifth, Z is a quarter. Find the probability that the thief is caught by policeman Z. Caught by policeman Z. So being caught by Z means the probability that X will miss, Y will miss, but Z catches them. So this means the probability of being missed by X. You know, being caught by X is a third. So being missed by X becomes 2/3. Then being caught by Y is a fifth. So being missed by Y is 4/5. Then now Z catches with a probability of a quarter. So to be caught by Z, because of course these policemen are now placed in respective positions the way they have been stated. For you to be caught by Z, X and Y must have missed you. And if we have the probability of them catching the thief, then what is the probability of them missing the thief? And I don't know the kind of a company here, which is storing very expensive jewelry, but the probabilities of the policemen they have employed to catch a thief is too low. I thought the probability of catching the thief should be higher than missing, because when X is just a third, it means there is 2/3 of missing. Then Y can catch a thief at a probability of a fifth. That means missing is 4/5. Higher chances of missing, 80% actually. Then Z, if Z catching is a quarter, it means Z missing is 3/4, which is 75%. So if I were the CEO of this particular company, I would immediately fire the policemen and employ different people. Anyway, we can now find the probability 2/3 by 4/5. And this should be multiplied now by a quarter. I'm getting 2/5, ladies and gentlemen. I hope if you're a student and you're following up, you're having some notebooks, you know what we are doing, and you can follow up, just affirming our work. So sometimes we can make an error. You don't think we are not that unique. Yeah, an error can happen. An error can happen, and in such a case, you are allowed to make a correction kindly. So from where we are, just know that errors can happen. As we proceed now to number 9. Yeah, we are proceeding very quickly. In number 9, we are told to solve the equation cosine squared of x minus 2 sine x equals to 2 for the range of values of x between 0 and positive 360. So with this, we start immediately by applying the trigonometric identity. This is trigonometry 3, whereby we say when we take the cosine squared of an angle plus the sine squared of the same angle, we usually get 1. So according to this, we can now make the cosine squared of this angle the subject. So 1 minus sine squared of an angle should give us cosine squared of the same angle. And therefore, we can now substitute at this point and say instead of cos squared, we can have 1 minus the sine squared of x, then minus 2 the sine of x equals to 2. That's the first step. From this, we can talk about the grouping of terms and all that. So actually, to do away with negatives, we can just have the sine squared of x coming to this side. Then negative 2 now becomes positive 2. The sine of x, then 2 minus 1, because this is already a 2 on the right-hand side, and 1 becomes positive there. So it will be plus 1. 1 becomes negative. 2 minus 1 is 1. Then we are remaining with a 0 here. This is a quadratic equation, ladies and gentlemen, or rather, we can let the sine of x to be another unknown, say even t, so that we have t squared plus 2t plus 1. This is equal to 0. If this is so, then now we can solve our quadratic equation. When we solve it, we'll be having a product of a by c, which is 1, and a sum, which is equal to sum, which is equal to 2. So this should be 1 and 1. Multiplied to give us 1, added to give us 2. So when you see the factors are the same, you should be concluding to yourself that this is likely to be a perfect square or an equation with repeated roots. With repeated roots means the value of t is just the same. So t, we remain with t plus 1. Then we factor out 1 to remain with t plus 1. This is equal to 0. So t plus 1 equals to 0. And also t plus 1 equals to 0. That is according to what is in the brackets. It's t plus 1. Outside the brackets, t plus 1. At this point, we can now say that t plus 1 is equal to 0, sorry, and the value of t equals to negative 1. Then what were we solving as t? We get back to this position and say the sine of x is now equal to negative 1, meaning that we can get x as the sine inverse of negative 1. Sine inverse of negative 1. So your calculator, shift sign, the negative 1, we are getting exactly, actually, instead of negative 1, let me give an hint of how to proceed at such a point. Sorry for rushing. Let me just take you slowly there. We can say this, that we need a value of x, or not even value of x. We can get a certain beta whereby the sine inverse of theta is 1, positive 1. This will give us 90. So now we ask ourselves, what was the sign of the sine here? When I talk sine, I mean plus or minus. Then there is the sign for trigonometric ratio. Sorry for that. I'm talking of this sign. And at the same time, the trigonometric ratio called sine. So we had a negative there. So we tell ourselves that we need an angle of 90 in the quadrants where signs are negative. So quadrants where signs are negative are, we can check them with the unit circle at this point. All of them, sines, tangents, cosines. So we say that where signs are negative is just the third, and also the fourth quadrants. So when we measure 90 in the third quadrant, because to measure these angles, we say in the first one, we pick theta. In the second, we pick 180 minus theta. In the third, it should be 180 plus theta. And in the fourth, should be 360 minus theta. 360 minus theta. I don't know why I'm already putting 90 there, sorry. So this angle, again, is going to be repeated because we measure it in the third quadrant as 180 plus 90. You know 180 plus 90 becomes 270. So the value of x is 270. Then we will also say that 360 minus 70 is also 270. So 270 is confirmed twice instead of becoming a different angle. So the value here is going to be 270 only. 270 only. Number 10. In the figure below, O is the center of the circle and A, if joined to B, passes through the center of the circle. So when we talk about A and B being connected to the center, to being A and B connected to pass through center, then we can interpret that one as a diameter. Yeah, this is a diameter. This one is a diameter. And actually, just for your information, you know, there are questions which will be set, and you will find that in case A and B are connected, they will not pass through the center, and we have to do it. So how are we supposed to do it? To find the center, because we must determine radius and also the center. I am going to show you the methods. That one I must show you. So we're supposed to say this. If A and B are connected to give us the center or to pass through the center, then center O of the circle shall be given as the midpoint. How do we calculate midpoint? The first x, 0, the second x, 6 over 2, comma, the first y, the second y, so over 2. This is going to give us 6 over 2, which is 3, and 8 over 2, which is 4. 8 over 2, which is 4. This is 3, 4. So the center of the circle as a coordinate, 6, 4. You're finding center, 3, 4. That one is done. Okay, I want to talk of the alternative way of expressing center. Remember, with a circle like this, then from origin O to B, that's a chord. And from O to B, okay, from O to A, that's another chord. So we're supposed to know that whenever we bisect a chord, we are supposed to pass through the center of a circle. Any perpendicular bisector of a chord passes through the center of a circle. So from origin to point B, there are 6 units here along the x-axis. 6 units from O to B, because it is coordinate 6, 0. That means if we bisect this chord, we must pass through the center, and we are at point 3. We are at point 3, 3 units from the origin. Then again, when we consider from O to A, because it is a y-intercept of 8, then it means there are 8 units here from A to the origin. We have 8 units. So if we bisect this chord, we must pass through the center, and we'll be having from 0 or from origin to this point, we'll be having 4 units. So we'll be at the 4th unit when we'll be bisecting that chord. So you can see 3 units and 4 units, they are meeting to give us the center as 3, 4. We start with the x value, 3, 4. So you can still analyze it that way. And actually, that is the surest method which you should adopt in this level, because sometimes you'll be given such that A and B are not being connected to meet at the center. So if they don't pass through the center, you should apply this method of bisecting the chords. When you bisect the chord, they meet at the center. So you consider the middle value of each chord that way. So we have it that way. Yeah, we have it that way. Then we can also talk about now the radius. Now that the axes are meeting at right angle there, and we are having 6 and 8 units, can we apply Pythagoras theorem and say, this one has very many methods again. Pythagoras theorem and say, when we take 8 squared and we add 6 squared, then we take square root, we should be able to get the length to be, which is our diameter in this case. So 8 squared and 6 squared then the square root is giving us 10. So the length AB is 10, meaning that the radius will be equal to 10 over 2, which is exactly 5 units. So the radius is 5 units. The radius equals to 5 units. So with 5 units there are very many methods again that we can repeat to get the same. For example, we can use what we call vectors. Assuming this is center C, then we can get the vector length from B to C. Yeah, the magnitude of a length, the magnitude of a vector BC. We just get the length, or we can get using the same vectors. The length of B to A to give us a diameter, we divide it by 2, or we can get directly A from C. The distance of A from C is the same as C to B in any direction. We can call it BC or CB, AC or CA. It is just the same. So we can just briefly explore that approach, whereby we say we can take just the magnitude of vector AC. We first get the magnitude of vector AC, 3, 4. We subtract 0, 8. This is going to be 3 and negative 4. Then to get now the magnitude, we'll need 3 squared plus negative 4, also squared. Then we take square root. This is going to be 9 plus 16, which is 25. The root of 25. The root of 25, which is 5 units. Yeah, 5 units. So we can have several approaches to the same. But anyway, it is already confirmed. It is already confirmed that the radius is 5 units. And part B of this particular question, we are taught to express the equation of the circle in the form x squared plus y squared plus ax plus by equals to 0. A and B are constants. Constants can be integers or otherwise. Anyway, we start expressing the general equation, which is given by x minus a, we square, y minus b square, radius is also squared. So we would, in this case, x, okay, a and b are the coordinates of the center of the circle. So x minus the x coordinate of the center, 3, then we'll be squaring, plus y minus 4, we square this, equals to radius, we also square. When we open brackets, this should be x squared minus 6x plus 9. Then we add y is also squared minus 8y plus 16 equals to 25. So I'm expanding using the quadratic identities. So I expect you to be knowing this. According to the order provided here, we're supposed to give the part with x squared first, then the part with y squared, the part with y squared. You know, this is a y squared. Then the parts with x, negative 6, x. We have the part with y, negative 8y, then equals to 0. That is the format needed. The reason why it is directly becoming 0 is because we are having 9 and 16 giving us 25. And when we take it to the right-hand side, it will be 25 minus 25, just becoming a 0. So that's a very technical set of a question, but a good one anyway. Number 11, as we wind up. The table below shows the monthly income tax rates for the year 2024. We have the monthly income in Kenya shillings. Then on the other side, we're having the tax rates as percentages. Mr. Michael, monthly earning comprises of a basic salary, ex Kenya shillings, and allowances amounting to 5,200. When Mr. Michael claims a monthly tax relief of 1056 Kenya shillings, His employer deducts from his earnings a total tax of 1282. Calculate the value of X. In this case, we're supposed to tell ourselves that there is something called the gross tax, which Michael would have paid if it were not for the relief. Therefore, this is the net tax paid plus the relief claimed. So when we add the relief claimed, we're supposed to get a gross tax of 2338. This is the gross tax payable by Michael. Then now we say we're supposed to tax a known amount until we get the tax given here. So from the first bracket, this is back taxation. From the first bracket, we're going to have 9880 multiplied by 10%. This is going to give 988. When you consider this tax, we are yet to reach 2338. So we continue taxing. And now we have a second bracket whereby we're going to tax 19 for 80 minus 9880. This gives us 9600. 9600 now is being taxed at the rate of 15%. So at the rate of 15%, what are we going to get? We multiply by 15%. This gives us 1440. 1440 that way. When we add 1440 and 988, we are getting a 2428. That means we are already beyond the tax for Mr. Mike. And if we are beyond the tax for Mr. Mike, then it will be very okay to say that now we only tax Mr. Mike. Final tax is in the second bracket. Therefore, I'm going to clean this one this way. I'll clean it this way. I'll say now we don't tax everything in the second bracket for Mr. Mike. What do we tax there? In the second bracket, we should be talking about a certain unknown amount is the one to be taxed at the rate of 15% to give us the remaining tax, so that the total is 2338. So what is the remaining tax? 2338 minus 988. This is 1350. So there is a remaining tax of 1350 at that point. Now this 1350 should come from a certain taxable income at the rate of 15%. Therefore, we can remain with X now by saying that the value of X taxed at 15% to give us 1330 shall be multiplied by 100 over 15. This gives us 9,000. So in the second bracket, we only tax 9,000. 9,000 taxed at 15% will give us 1350, so that the total tax adds up to 2338. With that, now we can get the taxable income. So the total taxable income now shall be this way. From the first bracket, 9880, and in the second bracket, 9K exactly. This shall be 18,880. 18,880 that way. 18,880 that way. So that is the taxable income. But now what are we finding? Calculating the value of X, which is the basic salary. Taxable income is usually given by basic salary plus taxable allowances. So 18,800 equals to X plus allowances for Mr. Mike 5200. So to remain with X, we need to pick 18,880. 18,880, not 18,800. Sorry for this. 18,880. Then we subtract 5200. This gives us 13,680. Yeah, 13,680. that way. We can proceed to number 12. A matrix M, 2, 1, 2, 2 maps an object, point A, xy to a point A prime, x1, y1. A matrix T, which is a 1, 2, 3, 1, maps A prime to A double prime, x2, y2. Find the matrix which maps A double prime back to A. This is called successive transformations. Those who have covered matrices and transformations. Successive or successive transformations, meaning that there is a matrix mapping. There is a matrix mapping. There is a matrix here, which is mapping A to A prime, and another one mapping A prime to A double prime. That means we have now the matrices are M and T. So the first one is M and the second one is T. You should know that when matrices are listed in this order, it means M was performed first, followed by T. So we can get a single matrix that would represent the successive transformation by multiplying the matrices in the order in which they were performed. So we start with the T, 1, 2, 3, 1. Then we have 2, 1, 2, 2. When listed in this order, the matrix written second was performed first. That is what you're supposed to know. So I multiply now. Row times column, 1 by 2, 2 by 2. So 1 by 2 is 2, 2 by 2 is 4. That gives us 6. Then the same row and the next column, 1 by 1 and 2 by 2. That is 1 plus 4, giving us 5 at this point. Then now we go to the next row, which is 3 by 2 and 1 by 2. So 3 times 2, 6. Then 1 by 2, 2. So giving us 6 plus 2, 8. Then again, the second row times the second column, 3 by 1 and 1 by 2. That is 3 plus 2, which is 5. So we have a matrix of transformation that would have represented the two of them. The matrix that would have represented the two of them is now as stated here. So with this, ladies and gentlemen, with this, we can talk about now a matrix that would reverse this one. We usually say when you have a matrix responsible for a certain transformation, then a matrix that can reverse the same transformation is the inverse of the matrix provided. So the inverse of what we are getting, is going to give us a matrix that can reverse whatever has been provided. Therefore, we're going to take the inverse of the provided matrix. So what is the inverse of this? We first get the determinant. The determinant shall be 6 by 5. That is product of the elements in the leading diagonal, the main diagonal, the principal diagonal, minus product of the elements in the other diagonal, 5 by 8. So 30 minus 40 gives us negative 10. That is the determinant. So for us to get the inverse, then we need to divide everything by 10, everything by negative 10. But now we cause some rearrangement. 5 takes this position, 6 takes this position. Then we will have the 5 here changing its sign together with the 8. So the elements in the main diagonal change their sign, while the elements in the other diagonal change side. In the main diagonal, we change positions. In the other diagonal, we change sign. Yeah, leading diagonal, we change direction. The other diagonal, we change sign. A very good paper. Actually, I just like the level of the paper. It's my hope that you guys are understanding what is happening. Remember, with this now, we can open these particular brackets and have the inverse as this part becomes negative 5. Then the other one positive because it's already negative. positive. Okay, I'm trying to multiply by 1 over 10, sorry. So this becomes 1 over 2, but with a negative. The other one, 1 over 2, but now without the negative. Then on the denominator, we shall have 4 over 5 positive, because it's already negative 10 over negative 10, and positive 8. So positive 8 over 5, positive 8 over 10, which is 4 over 5. And the next one shall be negative, because it is a positive number, 3 over 5. Ladies and gentlemen, this is the matrix which the examiner wanted to see. Number 13 now. 3 grades of coffee, that is A, B, and C, were mixed in the ratio. Look at this ratio. Ratio 1:2:3. The cost per kilogram of each of the grades A, B, and C were 700, 490, 630 respectively. Calculate the selling price per kg if a profit of 20% is to be realized. Let's get first the cost price of a kilogram. We are mixing 1 kilogram costing 700 with 2 kilograms, each costing 490, with 3 kilograms, each costing 630. Then this will be the cost of the mixture. But now per kilogram, we shall divide by the kilograms in this mixture. The kilograms are 1 plus 2 plus 3. So we'll be dividing by 6. What are we dividing by 6? 700 plus 2 by 490 plus 3 by 630. This is going to give us 3570. Then when we divide this by 6 kilograms, we discover that a kilogram has a price equal to this. This is the cost price of a kilogram, Kenya shillings. Now we ask ourselves, if this is the cost of a kilogram, then this particular shopkeeper is intending to make a profit of 20%. Then how much are they going to sell it? 120% of what we are just getting here. So we multiply by 120 over 100, and this will give us 714 Kenya shillings. Yeah, 714 Kenya shillings. Now at number 14, ladies and gentlemen, the gradient function of a curve is given by 4x power 3 plus 2x minus 1. If the curve passes through a point, -2, 1, find the equation of the curve. So we're supposed to tell ourselves this gradient function is always the differentiated function. In other words, dy dx. We have already differentiated y, and we are getting this. So how can we get back to y? By simply doing the derivative. Okay, if that was the derivative, now we do the integral. We integrate 4x power 3 plus 2x minus 1 with respect to x. So the value of y, or rather the function y, will be this power. The first power here increases. That becomes x power 4. Then the new power divides everything. So we get x power 4, because the new power, after dividing everything, then 4 will cancel out, plus in the next term, x is power 1. So power 1 increases to power 2. And also the 2 divides everything such that it just becomes x squared. Then from that point, we can talk of -1. X is power 0 at that point. Therefore, x becomes power 1. So 1, -1 by x, we get x. Then there is a constant now, the arbitrary constant of integration. So this is the general equation for y. But now we are given a coordinate where it passes. Then it means for this particular curve, when x equals to -2, the value of y is 1. So 1, we substitute to get the constant. So when x is -2, y is 1. So we have -2 has to be raised to power 4, and -2 should be raised to power 2, minus -2, then plus c. 1 equals to, 1 will be equals to negative 2 power 4. Then we are going to add negative 2 squared. Then we subtract negative 2. This is going to give us 22 plus C. How can you remain with C? By subtracting 22 from 1, which is negative 21. If that is negative 21, the value of C, then we can get our equation very conveniently by saying now y should be equal to x power 4 plus x power 2 minus x minus 21. So this is now the specific equation for the particular curve. A very good question again. Very good one. At number 15. We are winding up, ladies and gentlemen. Those who are joining us late, please remember to subscribe to this platform, Shifting Grades Online School. Complete the table below for curve y equals to x power 2 minus 2x. Then you are also told to draw the graph. After completing the table, you draw the graph. Then you use the graph to find the gradient when x equals to 2. When x equals to 2. Okay. Look at this. We just substitute in the equation to get the value of y. When x is 1, it shall be 1 squared minus 2 into 1. This is giving us negative 1. Then we proceed to 2. 2 squared minus 2 into 2. This gives us a 0. Then at 3, to be 3 squared minus 2 into 3. This gives us 3. Then 4. 4 squared minus 2 into 4. This gives us 8. So we have the table already filled. Then now we can plot from negative 1 all the way to 8. The values of y might be limited because we need 9 of them. So you will allow me to use a very different interval for the y-axis. Very different interval for the y-axis. For x, we don't need the negatives that much. We really don't need the negatives that much. So we can start with 0, negative 1. Then we can talk about 1, 2, 3, 4 that way. Then now we can even have 5 that way. Then for the y, we can have intervals of 2, 4, 6, 8, 10, such a thing. Then negative 2, negative 4, like that. We start now plotting coordinates. We start with a negative 1, negative 1. So 1, negative 1 shall be here, because negative 1 is on the lower side. Then 2, 0 shall be here. 2, 0 shall be there. Then 3 goes with 3. So 3, 3 shall be this point. 3, 3 shall be there. Then 4, 8. So 4, 8, this point, 4, 8. So with the coordinates, we can now come up with the curve. Come up with the curve, make it as smooth as possible. Yeah, that's now the curve already plotted. We have the curve that way. Now with the curve, we get back to the question again. Find the gradient when x is 2. When x is 2. So at x is 2, we are just supposed to draw a tangent at that particular point. You draw a tangent at that particular point, and you find the gradient of that tangent. the gradient of a tangent to a curve at a point equals the gradient of the curve at the same point. So the gradient of a tangent that passes through 2 is the gradient of the curve at point 2. Remember, the gradient of a curve usually varies from constant or from a point to point. So that's a tangent. We can now calculate gradient of this particular tangent. And how do we get gradient of this tangent? We need to say that is 0.20. We just pick any coordinate, and we can also pick another coordinate like 1, -2, a coordinate that passes through the line. So how do we get the gradient? We'll be talking about 0 minus -2 out of 2 minus 1. So this is going to be +2 over 1, which is just 2. So the gradient is 2. Okay, because this is from a graph, which anyway, we can estimate the values, can we compare it with the gradient by calculation? Gradient by calculation shall be gradient function dy dx. According to the function, this becomes 2x minus 2. So now we say at x equals to 2, what are we going to get as the gradient? This will be 2 into 2 minus 2. When we take 4 minus 2, we get 2. So by calculation, it is 2. And from our graph, that means we have drawn our tangent very accurately. We are also getting 2. So that is how we can compare the two. Very well calculated. Look at number 16. The difference between the fourth and the seventh terms of an increasing arithmetic progression is 12. Calculate the sum of the first 15 terms of the progression. If the first term is 9, we are supposed to know how to get nth term. Nth term in an AP. Nth term in an AP is given by a plus n minus 1 multiplied by d. So when we talk about the difference between fourth and seventh, one thing that you're supposed to understand, there is an instruction here which is not supposed to be taken for granted. The word increasing. The word increasing is very important in this particular question. You know, when we are told the difference and they don't write the word increasing, the difference, we can pick fourth minus seventh. But now when we are told that it is an increasing arithmetic progression, then it means the seventh term, is greater than the fourth. So seventh term is going to be a plus 7 minus 1, then multiplied by d. When we subtract the fourth term, which is a, then 4 minus 1, 3 multiplied by d, we're supposed to get 12. Because according to an increasing arithmetic progression, seventh term is supposed to be greater than the fourth term. Unless the difference was negative, then we would have concluded that it is the other way around. But we have a positive difference. Yeah. So let's talk about now a plus 6d minus a minus 3d to give us 12. So with this, we can say a cancels out. Then 3d is equal to 12. Then the value of d is 4. The value of a is given. The first term is 9. So we have the first term and we have the common difference for this particular arithmetic progression. So with such a question, ladies and gentlemen, we can proceed to talk about sum of the first 15 terms. We have two methods here. To proceed, we can use two methods. Method 1, we know that the sum of a given number of terms is given by n over 2 into 2a plus n minus 1 multiplied by d. So we talk about 15 over 2 by the first term plus 15 minus 1 multiplied by 4. This is 15 over 2 into 18 plus 14 by 4. This gives us 56. So 56 plus 18, this becomes 74 times 15 over 2. This gives us 555. So that is the sum of the first 15 terms. We can choose another method here, which says sum of a given number of terms is n over 2 into first term plus the last term. So the first thing to find in such a case, is the last term. Last term means the 15th term. So 15th term shall be first term plus 15 minus 1 into d. So 9 plus 56, I think, which is 14 by 4. Yeah. 9 plus 56. This gives us 65. So in this case, now we'll be talking about 15 over 2 into the first term, 9, plus the last term, 65. This should be 15 over 2 into 74. 15 over 2 by 74 will give us the same answer, 555. That too. So we can approach the question using any of those two methods. This is number 16, the last question in the section 1. Thank you so much for following up. Remember our programs here, whereby we'll be doing the one-term program by covering term 1 work of 2026 with continuing students, both the junior school and also the senior school. Please register for this. All the candidates in day school are having a very serious program every weekend. Saturdays, we are having the JS students, KJCR candidates, and every Sunday, we are having the senior school students, the KCSE students, 2025. So you must register for this and make sure you reach out to us through our number. Thank you. Thank you for turning up. See you another time.